to equations by graphing on our calculator. So we know that to solve these things, we've been saying set them equal to 0, factor them. But we're going to look at when we have maybe some polynomials of higher degree, how we can solve these equations, these polynomial equations on our calculator. So if you look here, I've got one polynomial equals another. Typically, we say get everything on one side. What we're going to do now is we're going to look at these as two separate equations, like y1 is that equation and y2 is that equation. And solving those for x means the x values. Okay, it means the x values at which the two graphs intersect. Oh, it happened again. Okay. All right, so what we want to do is we want to treat those as two different equations, and the x-coordinates where they intersect, those are the solutions, okay? So let's look at our method 1, intersect feature. First, I want to graph them in y1 and y2, each side of the equation. So I go to y equals. I'm going to clear out my y1. On y1, I want the left side of this equation. So x to the third, and then I hit the arrow to go back down, plus x squared. That's our left side of the equation. And on the right side, we'll put our other equation, x minus 1. So when I hit the graph, I see where these graphs intersect. These only look to intersect once. So the solutions, why is this not working? Oh, the Apple Pencil's dead. All right, well, the solutions we'll look over here on the graph are going to be anywhere where they intersect. So I've got a lot of wasted space on the left and the right, so I'm going to change my window. I'm going to bring it into an x min. To tighten it up on the left side, I'm going to start it at -5 again. And to tighten it up on the right side, I'm going to end it at 5. So I just made my x min and max go from -5 to 5. That gives me a little bit of a closer look at these two graphs, okay? And so, this pen just completely died. And so I want to find where they intersect. That's going to be the x's that make this equation true, our real solutions, okay? So what happens here is, if I want to find that intersect, that's going to be on our calculate menu again. So I hit the second feature and calculate, and I do intersect, number 5. Okay? So now what I want to do here is they want to know which curve. What's your first curve? Now this is where the color calculators are nice. The blue curve, everything's in blue. They're saying, is your first curve this? y1 equals blah, blah, blah. You just say yes. Hit enter. You're essentially saying yes. Now it's going to put the cursor on the other curve. It's saying, is your second curve this red curve that you want to find out where they intersect? You hit enter and say yes. Now it wants a guess. What's the x value where it looks like these meet up? I'm going to say -2. And it shows me exactly where they meet up. And it gives me the x-coordinate and the y-coordinate. I only care about the x-coordinate because this equation had x's in it, right? So if we look at the graph, it's telling us the coordinates of that point where they intersect. And all we really care about is the x-coordinate because that will be the solution to this equation. All right, so step 1 is to graph both of those. Step 2 is to use our intersection feature to find the x values of the points of intersection. So where did these intersect? At -1.839. So the solutions are x, and there's only one solution because there's only one spot where they intersect. Only one real solution. So my eyes, I can't see, that's so small. 1.839, and it's negative. So -1.839. That's our solution to this equation. We didn't have to do any factoring and this and that, right? We just solved it. Method 2 is a crappy method, so we're just not going to do it. I'm not going to really tell you about how to do it. What we will do is we'll look back at some of these other equations that we wanted to solve, through other techniques and see if we can solve them just by graphing. Let me see if I can find a good one. I don't love any of these. Let's see what this one looks like. I'm going to go to y equals. And in y1, I'm going to put x cubed. And then in y2, I'm going to put 8x minus 2x squared. I want a graph. Looks like they intersect twice. So it looks like this will have two real solutions. So I'm going to go second, calculate, and I want to find where they intersect. So that's number 5. So it's asking you, is your first curve the blue curve? Now it's hard to tell because it's the same spot if you don't have the color. That's why you want to pay attention to the equation. So I say, yeah, that's the first curve I want to find. Then the second curve, yes, and I want to find where they meet up, and it wants a guess. And I'm going to leave it right where it is because it looks like that's a good guess. I hit enter, and it tells me the intersection occurs at 0, 0. So that means that x equals 0 is one solution, or the other solution is the other spot where they intersect. So I'm going to go over here and go second, calculate, intersect, which is number 5. They say, is your first curve this blue one? I'm going to say yes. Is your second curve this red one, which the equation's right there? I'm going to say yes. And then they want to guess. Now I'm looking for this point of intersection. It looks like it's around an x value of 2. So I'm going to hit 2 for my guess. And it's telling me it's intersecting, at 2, 8. Now to solve the equations, we only care about the x values. So there's those two equations, the two solutions to those equations. As a reminder, here's how we would have done it without the calculator. We want to make it equal to 0, so I'm going to get x cubed plus 2x squared minus 8x equals 0. I'm going to bring all this stuff to that side, and now I'm going to try to factor. Well, they have a common factor of x, so I'm going to set up my little common factor routine here, and I've got x squared plus 2x minus 8. Now I'm going to see if I can factor this trinomial. I know it's going to start off x and x. What numbers multiply to negative 8 but add to 2? That's going to be, let's see. Is this going to work out? Maybe it's not. 4 and 2? Yeah, so x plus 4 and x minus 2, right? So we've got, that would be negative 8, and that would add to positive 2. So I'm finding 3 solutions here because x plus 4 equals 0 and x minus 2 equals 0. So I've got x equals 0, x equals negative 4, and x equals 2 if I solve those. So why did the calculator not get that x equals negative 4? Maybe it did and I just didn't see it. So here's some limitations to the calculator. If we come back to the calculator, we see that, wait a second, this blue one and this red one, they may intersect later on down the road. Now remember, because this is a cubic polynomial, that means you may have up to 3 solutions. So I got to check for that. Are these going to intersect somewhere down here? So I want to look way further down. So I'm going to go to my window, and my y min, it goes only down to negative 10. I'm going to make it go down to negative 20 and see if that's far enough. It looks like they're getting a little closer, so I'm going to try again. And I'm going to make it go all the way down to negative 50 and see if that gets me a good enough of a look. And I don't care about the others, so maybe I'll even bring my y max down with it. I'll just say it's like 1, just because. I'm just looking down here. Ooh, I almost got it. So I'm going to go even lower than 50. I'm going to go down to negative 75. So this will show, this kind of is a nice way to show us some of the limitations of the calculator. You have to really know how to work this window. And now I see that third point of intersection. So now that I see it, I can calculate it. Second, calculate. Number 5 is intersect. So I go, the first curve is the blue curve. I say yes. The second curve is the red curve. I say yes. and they want to guess. It looks like it's at -1, 2, 3, 4. -4 is my guess. Oh yeah, that's what it was because we did it before. So I hit enter and it tells me, yes, the intersection was at -4, negative whatever that y value is. So that's our third one. So that is a problem with the graphing. You do have to worry about your window. So you have to have, so you can't just not do any thinking. Whether you're using the calculator or you're solving through some of the other techniques, it's kind of like you got to think about all the stuff that's going on and tie everything together. Like, since this is a cubic equation, it can have up to 3 solutions. So you shouldn't be satisfied when you only have 2. I should have thought maybe there's a third one and start searching for it. Okay? So thanks for watching, and I'll give you some practice on this. Oh, that's